Welcome to the Deep Dive. Today we're tackling a really old mystery, actually. How did we humans first figure out how to write?
Yeah, it's a fundamental question.
And get this, there's a seriously cool twist involving cutting-edge AI that might shed some light on it. Now, we know you're here to get smart quickly on stuff that matters, and that's what we aim for. Think of this as your fast track to understanding a huge moment in human history, but seen through the lens of some very clever machines.
Right. So we've been digging into a Perplexity article that breaks down a research paper. It's called Visual Theory of Mind Enables the Invention of Proto-Writing. We also looked at parts of the actual ArcSpef preprint itself.
The preprint. Okay. So like the early version.
Exactly. Shared before the final peer-reviewed publication. And our goal really is to explore how our ancestors might have started writing and how this AI research gives us a fresh angle using this idea of visual theory of mind.
Visual theory of mind. Okay, that sounds key. So what is that exactly, in simple terms? And why is it potentially like this secret sauce for inventing writing?
Well, simply put, it's the ability to understand how someone else sees things visually. Recognizing that what you see isn't automatically what I see. And really crucially for writing, it's understanding how someone else will likely interpret a visual sign that you make.
Got it.
And the researchers are basically arguing this was probably fundamental for those very first steps towards, proto-writing.
Right, yeah, that makes sense. If you're drawing something in the sand, you need some idea if the other person is going to get it right.
Exactly.
So when I think about early writing, I usually picture, cave paintings, maybe Egyptian hieroglyphics. What's the sort of traditional view on how it all began?
Yeah, that's pretty much it. The conventional idea is that it often kicked off with iconic pictographs.
Iconic meaning?
Meaning simple drawings that visually look like the thing they represent. Think early Sumerian tablets, Egyptian hieroglyphs, little pictures of people, animals, objects. The idea was the meaning is kind of obvious from the picture itself, like a squiggle for water.
Okay, picture equals thing. Seems straightforward enough. So where does this new AI research fit in? Does it challenge that or add a new layer?
This is where it gets really interesting. Benjamin Spiegel and his team at Brown University used AI to explore this. They set up the simulated world. They called it the Signification Game.
Signification Game. Okay,
yeah.
Tell me more. What were the AI agents doing in this game? Were they like little virtual cavemen learning symbols?
Sort of. They communicated by drawing splines, which are basically just curves, onto a shared digital canvas.
Okay.
But the key thing is they weren't given any language, no rules about communication beforehand. They started completely from scratch.
Wow.
They just learned through reinforcement learning, trial and error, figuring out what drawings worked to get their point across in the game.
So no instruction manual. Just figure out how to talk visually. What was the point of the game? What were they trying to achieve?
The main goal was just to see how communication strategies would emerge naturally. Could these agents develop ways to signal meaning to each other without being told how?
And did they? Did they start sketching little pictures? Did they basically invent their own writing?
Amazingly, yes. That's a huge finding. These AI agents, just doing their thing in this simulation, actually developed systems you could call proto-writing.
No way.
Yeah, they started using their drawings to communicate effectively. So the big headline is, AI, from a blank slate, independently reinvented something very much like the first steps humans took towards writing.
That is genuinely astounding. Okay, so how does this connect back to that visual theory of mind idea? What was going on inside these AI minds, so to speak?
Right. This is where that concept really comes into play. The agents didn't just make random marks. They learned to create pictographs that were visually distinctive.
Distinct to how?
Meaning they were designed to clearly represent one thing and be easily told apart from drawings of other things. And the receiver agent, it learned to interpret these drawings by thinking about what the sender might have meant, considering other possibilities. So that ability to reason about how your drawing will be perceived and interpreted by another agent, that's visual theory of mind in action here. It's like anticipating the other guy's visual viewpoint.
So it wasn't just draw something that looks like X. It was draw something in a way that I predict the other agent will recognize as X. That feels like a big step.
It is a fundamental leap.
Now, you hear a lot these days about theory of mind in like ChatGPT and other big language models. How does this research compare? Is it the same thing?
That's a really good distinction to make. While there's definitely buzz about theory of mind in LLMs, a lot of experts are still pretty cautious, maybe even skeptical about those claims. Spiegel's work here is much more focused. It gives a arguably more convincing demonstration of visual theory of mind in a very specific, controlled setting. It's not about understanding human emotions or complex stories like in the LLM debates. It's purely about reasoning about visual perception for communication.
Okay, so more precise, maybe more verifiable in this context. Now, one puzzle with early writing is going from drawing concrete stuff, like a bird, to showing abstract ideas. The paper talks about a signification gap. What's that?
Yeah, the signification gap is basically the challenge of representing complex or abstract concepts using just simple pictures. I mean, how do you draw justice or tomorrow?
Exactly. You can draw sun easy enough, but sunrise, a bit harder. So how do the AI agents handle that? How did they bridge this gap in the signification game?
They bridged it using their visual theory of mind. Instead of just trying to make a perfect visual copy, which, as you said, is often impossible for abstract things, they focused on making a drawing that, given the context, would best steer the receiver to the right meaning.
Ah, so they were thinking ahead.
Exactly. Thinking about how the drawing would likely be interpreted, this inferential approach, thinking from the receiver's perspective, worked much better than just, simple reward-based learning without that understanding.
That's really clever. They weren't just copycats. They were strategic designers of signals.
Right.
Did the drawings themselves change over time? Did their style evolve?
Oh, absolutely. The research showed a clear evolution. At first, the agents tended to make more detailed, iconic drawings, ones that looked quite a bit like the thing.
Okay, literal pictures.
Right. But as they interacted more, as their communication got more fluent, the drawings often became more stylized, more abstract, less detailed.
Huh. That sounds incredibly familiar. Like, that's exactly what happened with human writing systems, isn't it?
Precisely. The path the AI took mirrors the history of human writing remarkably well. Think about Egyptian hieroglyphs, started pictorial, then evolved into more abstract, cursive forms like hieratic script.
Well, cuneiform.
Or Sumerian cuneiform, yeah. Going from recognizable pictures to those abstract wedge shapes. This parallel strongly suggests there might be some fundamental cognitive process going on, whether it's in our brains or in silicon.
That's a really powerful connection. The paper also uses the term mirror cognition for the AI model. What's that about?
So mirror cognition here is about how the agents were built to understand each other. Basically, they used models of their own perception and action systems to try and predict how another agent would perceive their drawing.
So, like, how would I see this if I were looking at it?
Kind of, yeah. It's like trying to get inside the other agent's head, visually speaking, by running a simulation on yourself. If I made this mark, how would I interpret it? So maybe that's how the other agent will interpret it.
Okay, using your own experience to model the other. Sounds like a core part of theory of mind.
It really is. And this whole inferential communication model they built relies on two main assumptions. First, that the agents share a similar way of classifying things they see and reacting, which is simulated by this mirror cognition.
Okay, shared baseline.
And second, that they can explore the different kinds of drawings they could make, the space of pictographs. And they did that in the AI by just generating and interpreting their own drawings.
Makes sense. And they use different data sets too, right? Something called SAFAR 100. What was the point of switching data sets?
Right. SAFAR 100 is a data set with more natural, complex images, lots of different objects, more visual detail than the first data set they used, which was mostly handwritten numbers.
Harder pictures to draw.
Exactly.
Okay.
It created a bigger signification gap. It made it harder to represent things visually, testing the communication system under more challenging, maybe more realistic conditions.
A tougher test for the AI artists. Got it. The paper also talks about reference sensitivity. PREF. What does that measure?
PREF, or reference sensitivity, it's basically how likely a receiver agent is to recognize a drawing as representing a specific thing, the referent.
Okay.
And interestingly, they found that things that are inherently harder to draw well, they tend to get a higher PREF score.
Wait, harder things are easier to recognize. That seems backward.
No. It means the receiver is more willing to accept an imperfect drawing if the thing itself is known to be difficult to draw.
Ah, okay. That makes sense.
Yeah. If drawing a bicycle is really tough with just simple curves, the receiver learns to be more lenient and interpret even a rough attempt as bicycle. It helps compensate for that signification gap.
Right. Okay. So the receiver cuts the sender some slack if the task is hard, clever.
Yeah.
And they also contrasted behaviorist signaling with inferential signaling. What's the difference there?
So in their models, the behaviorist agents were the ones learning mainly through simple rewards. Did the communication work? Yes, no. These guys struggled with abstract symbols because they weren't really reasoning about the receiver.
Just stimulus response.
Pretty much. But the inferential agents, the ones using visual theory of mind, they could communicate effectively, even with fairly basic iconic drawings, because they were actively thinking about how the signal would land, how it would be interpreted.
It's that extra layer of thinking about the other agent's mind.
That's the key difference. It's the internal reasoning about the other's perspective.
And did things like the environment matter? The paper mentioned penalties for size or complexity of drawings.
Yeah, absolutely. They found that adding constraints like penalties for drawings that were too big or used too many curves really influenced how the symbols evolved.
Pushed them to be simpler.
Exactly. Pushed them towards more efficient, less visually complex forms over time, which, again, seems to mirror how real-world factors, like the type of clay tablet or reed brush available, probably influenced early human writing systems.
Okay, so pulling this all together.
Yeah.
What's the big takeaway? The main insight from all this AI simulation about how writing started?
I think the core insight is that this research provides pretty compelling evidence that visual theory of mind, that ability to think about how others see and interpret visual signs, might have been a crucial cognitive step needed for humans to invent writing in the first place.
So it wasn't just about being able to make marks.
Right. It wasn't just the motor skill. It was having the mental capacity to anticipate how those marks would be understood by someone else. That seems to have been key.
So this AI work really bolsters the idea that a specific cognitive ability paved the way for one of our species' biggest inventions. Being able to put yourself in someone else's visual shoes was maybe critical for creating shared meaning with symbols.
Precisely. And the way the AI's journey mirrored the path of human writing systems. That parallel is really striking. It suggests something fundamental about how communication systems like this might evolve.
This has been, wow, a really fascinating deep dive. It's amazing that studying AI can give us clues about something so ancient and human.
Yeah.
So as we wrap up, what's a final thought for our listeners? Something to chew on.
Well, maybe think about how this idea of visual communication being potentially linked to visual theory of mind might connect to other kinds of communication.
Like what?
Well, gestures, for instance, or sign languages, even maybe animal signals. Could similar cognitive gears be turning there? What does it all tell us about our fundamental capacity as humans to create and grasp shared meaning in all sorts of ways?
That's a great question to ponder. How deep does this ability to understand another's perspective really go? Thank you for taking this deep dive with us today.
My pleasure.
We definitely encourage you to think about those connections and maybe even look up the research yourself. Until our next exploration, keep asking questions.